And here we want to talk about convergence and divergence of infinite series. So a series like this is called the infinite series. And so we have summation of I from 1 to infinity of a sub I. And then this means that's just the sum of the first term, the second term, the third term, the n minus 1 term, the nth term. And next, we have what's called sequence of partial sums. So we let S sub 1 be the first term, S sub 2 be the sum of the first two terms, S sub 3 be the sum of the first three terms, S sub 4 be the sum of the first four terms, S sub 5 be the sum of the first five terms. Then S sub n minus 1 will be the sum of the first n minus 1 terms. S sub n will be the sum of the first n terms. And the sequence S sub 1, S sub 2, S sub 3, S sub 4, S sub n minus 1, S sub n, and so on. This is called a sequence of partial sums. For the infinite series, this is how we write the infinite series using partial sums. To be S sub k and allow k to run to infinities. So S sub k with k running to infinity is the infinite sums, infinite series right here. And we say that this infinite series converges to some real number if the limit of S sub k, or the limit of the sequence of partial sums, converges to some real number, and we call that number S. And this infinite series, we say that it diverges if this limit here does not exist, or it diverges. And now let's look at an example. Here we have the infinite series of summation of 1 divided by n plus 1 minus 1 divided by n plus 2. We want to show that if we add all the terms together, this series will converges to 1/2. The first term would be 1, that's when n is 1. We put a 1 here, then we get 1/2 minus 1/3. The second term, that's when n is 2, then we get 1/3 minus 1/4. And then we get to the 10th term, that's when n is 10, and n is 10 here, then we get 11 and 12. So this would be 11, this would be 12. So this is the sum of the first 10 terms, and if we run this program here, then if we add the first 10 terms together, then we get 0.41666666. This is the sum of the first 100 terms. So when n is 100, we get 101 here. Here we get 102. And now let's add the first 100 terms together. And we get 0.490490196. And now let's add these first 1,000 terms together. Then we get 0.4900199. Now let's add the first 10,000 terms together. And we get 0.4999001. And now let's add the first 10,000 terms together. This is the 100,000 terms. And for the first 100,000 terms, we get 0.4 is 999. And so when n is 10, the sum of the first 10 terms is 0.4166. When n is 100, the sum of the first 100 terms is 0.49019. When n is 1,000, we get 0.0499. And when n is 10,000, we get 0.4999. And then when n is 100,000, we get 0.499. So what we see in here is this: as n gets larger and larger and larger, this sequence of partial sums is moving towards 0.05 or 1/2. So we say that the sequence of partial sum approaches 1/2. And this infinite series is the same as, it's always, since the sequence of partial sum is approaching 1/2, we say that this infinite series converges to 1/2. But that we're just doing, we got this number by using the summation, program. But now let's analyze this and show that we do get 1/2. The sum of the first k terms, and then the a sub 1 plus a sub 2, a sub 3, a sub 4, and then the last term would be a sub k, and the term before a sub k is a sub k minus 1, and the term before that is a sub k minus 2. So the first term would be when n is 1. And so when n is 1, we get 1/2. When n is 1, we get 1/3. So 1/2 minus 1/3. So this is term number 1. And this is term number 2. This is term number 3. This is term number 4. For the k minus 2 term, then in the place of n, we have k minus 2, k minus 2. For the k minus 1 term, in the place of n, we put k minus 1, k minus 1. And then for the kth term, in the place of n, we just put k and k. And then note the following. This is negative 1/3 plus 1/3, so that will cancel out. This is minus 1/4 plus 1/4, so this will cancel out. Minus 1/5 and 1/5, this will cancel out, that will cancel out. And then eventually this 1/6 will cancel out with the next term. And then when we get here, this will cancel out. Now k minus 1 plus 1, k minus 2 plus 1 is k minus 1. And then k minus 2 plus 2 is just k. K minus 1 plus 1 is just k. And then k minus 1 plus 2 is k plus 1. And then right here we get k plus 1, k plus 2. And so as we did right here, that term and then that will cancel it out. And then that will cancel it out. And then right here we have minus 1 over k, and then plus 1 over k, that will drop out. And then minus 1 over k plus 1, that will drop out with this one. So for the infinite series, what's left is 1/2 minus 1 over k plus 2. And just as we have just shown that the s sub k, what's left is 1/2 minus 1 over k plus 2. And so the sum This infinite series is the same as the limit of s sub k as k runs to infinity. But we found that s sub k is 1/2 minus 1 over k plus 2. As k runs to infinity, limit of the constant 1/2 is just 1/2. And then k runs to infinity, this term will go to 0. So we have 1/2 minus 0, which is 1/2. And we saw earlier that when we used the simulation program, the series was approaching, the infinite series was approaching 0.99999 or 1/2. This type of series, we call it a telescoping series. So this type of series is called a telescoping series.